Okay, so this is a short training for Rhino and Grasshopper Tekla Live Link. And in this example, we're going to create this twisted column in this Rhino Grasshopper Tekla Live training. Okay, let's start with this presentation first on our PowerPoint. So, just want to introduce first to you the Tekla Elements in Grasshopper. So basically, if you install the live link in Tekla in Grasshopper, so you will find this Tekla 2022 in the tab of Grasshopper, and under that Tekla 2022 tab, so this is the mirror of the elements that can be seen in Tekla structure. So you will find the steel beam, columns and plates, the concrete beam, construction line, cuts and fittings, items, component, and so on. And in Grasshopper uh, elements, okay, these are some basic commands that you can find in the Grasshopper. So as you can see here, there are some commands here that you can use in this example. One of those are the XYZ factor, wherein you can use this X and Y and Z coordinates, or maybe some in future you can use also this mathematical equation or operation like addition, subtraction, multiplication, and division. And there are some commands here that you will find inside the Grasshopper. Okay, so to start with this project, basically you need to open the Tekla Structure software first. Okay, so just open the whatever version you have. So at the moment I have the 2022 version of Tekla Structure. And after that, once you open the Tekla Structure, you can now open the Rhino. So this is the Rhino application. You can use also the latest Rhino application or whatever you have in your computer. So after that, then under the Rhino, you can find or you can type the under the command of Rhino software, you can type the Grasshopper. All right. So once you type the Grasshopper, then the Grasshopper application or program will be shown in your screen. So we can start with this one. So I have already my Tekla structure on the right hand side, and on the left this is the Rhino. And then under this command, I can just simply type Grasshopper. Okay. So just open the Grasshopper. And then once you open the Grasshopper, you can just simply close this window here. And then you can leave the Grasshopper on the top and then the Rhino, or I can put that one at the bottom. So this one will be the setup in my screen. So I have my Rhino at the bottom and then the Grasshopper on the top. So this one ideally is best to create in a what I call that in a two monitor. Okay, so if you have three monitors, then that will be the best, but again, at least it's recommended to have at least two monitor with you, so you can use one monitor for the Tekla structure and the other monitor for the Grasshopper and the Rhino software. Okay, so let's go back to our presentation and let's get started. So to start with this project or this example, the first thing we need to do is to add a rectangle. So on your Rhino or on your Grasshopper canvas, you need to type the rectangle. Okay, and then here, set one rectangle to a Rhino, meaning you need to pick 2 points. Okay, let's do this one first, and then we can go to our Grasshopper. Okay, so here just double click the canvas, and then you type here rectangle. And then you will find this rectangle here contains a collection of rectangle, this one. So there are some rectangle here, but I want you to select this rectangle here, contains a collection of rectangle. Just click here, all right? So from this rectangle here, all you have to do is just simply right click and then set one rectangle and then pick that one from the Rhino. So this is the Rhino uh, um, model. Just pick 2 points, 1 and then 2, and there you go. So you have now the rectangle there. Okay, so that's rectangle. You cannot select this one in the Rhino because that one is created using the rectangle under the Grasshopper. Okay, now let's move on. So the next step, we'll go back to our PowerPoint again, so that you can easily follow what I'm trying to do here. Okay, so the next step is we need to create a box rectangle. So meaning we're going to connect the rectangle to the box rectangle, enable for us to create this what we call the 3D rectangle in our Rhino. So you need to type box rectangle. Again, go back to the canvas. Just simply double click on this one. Double click and then you type here box rectangle, and then you will find this one, box rectangle. So you can identify this one with the height. So meaning I have the rectangle here, and then if I'm going to link now my rectangle to the box rectangle, you will see the outcome here in Rhino. And then we need to add the height. So for the height, again, you need to add the slider. So for the slider, you can type slider here, okay, and use the number slider. Or you can just simply, again, double click the canvas, and then you can type the value. For the slider, you can specify the minimum and the maximum. So in order for us to do that one, you can just simply go to your number. You can just simply type the number. Let's say the minimum is 1,000, and then double that, and that, okay? And then type 5,000, which is the maximum, okay? So your slider will play along this value, 1,000 to 5,000. Enter that, and then as you can see here, minimum you cannot go less than 1,000, and then the maximum will be 5,000. So here, if I'm going to link this one to my height, look what will happen. So there you go. I have now this 1,000 rectangle here. But if you notice here, I think this one is a bit, I created a small, what I call that, a small rectangle here. So if you want to recreate a rectangle, it's still okay. You can still do that one. All you have to do is to select this rectangle and then right click and then clear values. So this one will be deleted. So here, again, select the rectangle and then right click and then set one rectangle and then make it a bigger rectangle. All right, so there you go. Okay, so you can still delete and then redo it again by simply right click and then clear values and then set one rectangle again. Okay. All right, so now we have the rectangle in our Rhino here, and then again, let's move back to our PowerPoint, and then let's go to the next page. So here in the next page, okay, in the next page, we are going to create a polar array, okay? So we need to add a polar array for this rectangle. So enable for us to do that one, again, we need to go back to to our canvas and then type polar array and also change the count. So meaning we can add we can add the value to the count of this polar array. So again, going back to the canvas here, just simply double click on the canvas here and then you type here polar and then look for the polar array. There you go. And then now you will notice that this rectangle is connected to the rectangle on the box. So I'm going to put this polar array in between this rectangle, and then I reconnect the rectangle to the geometry, and then this geometry will move to this rectangle. There you go. So as you can see, it already have the array. But again, I need to control the number of this array. Again, I can just simply double click the slider, and then maybe the minimum is let's say the minimum is 4, and then by 10. So meaning I have only 4 up to 10 numbers of count here. Let's say I put 6, and then link this one to the count. So here. So by the way, this slider, you can rename this one. Let's say number of slider. Instead of number of slider, I can just simply right click, and then under the right click, you can just simply click here count, or maybe number of footing. Okay, and then this one is, instead of number of slider, then this one will be the height of footing. So you can easily identify what is this what is the value of this, or what is the name of this what do you call that, parts or elements. Okay, so now next is into the next page. So here, as you can see here, if you want to move, okay, the position of your box or foundation in the Rhino. So this is how to control using the Rhino point. So meaning we need to add the point here in the Rhino, and then by moving around this point, then this one will move inside the model. But we need to add the move command, and then we need to add the point. Okay, so and we need to link that one under the rectangle, and then in the geometry here in the polar array. So just remember, add the move command and then the point in the canvas. Okay, so again, let's move on to the canvas. So again, here, I'll just simply stretch this out a little bit, and then double click, and then you type here move. Okay, so move. So here, as you can see here, again, I put that one in the middle of the polar array and rectangle, like what I did earlier for the polar array and the both rectangle. So this time, I will put the move command in between the rectangle and the geometry. So again, put that one on the geometry, and then this one under the geometry, and there you go. But we need to put the motion. So for the motion, I need to type here point. Okay, so if you notice here, there is a point. So there is a Tekla point and there is a Rhino point. So I'll just click this point, and then look here, I can just simply right click on this one, and then set one point, and then pick the point anywhere in this Rhino page or software. So just click any point here. So as you can see here, this point, if you select, then it becomes green. And then now I'm going to link this one to the motion, so that now I can easily control the position. So look, if I select this point, it will highlight here, so I can move around. See, I can move around. Okay. Okay, now let's go back to the our PowerPoint and the next page. Okay, for the next page, this time around, we're going to bring the boxes, or we're going to bring the footing to Tekla Structure software. Okay, so enable for us to do that one. All right, so we are going to add the slab. So under the Tekla Structure or the Tekla tab 2022, we need to add the slab. Okay, we need to add the slab. So as you can see here, we are going to add the slab and then link the boundary. Okay, the boundary to the slab, and we're going to use also the height to the profile of the slab, because in Tekla Structure, the profile of the slab is the thickness, or which is the height of the box. Okay, so again, let's move back to the canvas, and then here we can now type the slab, or select the Tekla 2022 and then look for the slab here. Yeah. So for the profile, I'm going to link this one to the profile. And then the geometry, this is the polar array. So I'm going to put that one on the boundary. And there you go. So this is the Tekla structure. So again, if I'm going to pick the point, so here, if I move the point here, see, the Tekla structure also move. All right? And then here, this is the thickness, 1,001 meter thickness. Okay, so now, let's move on. Now, in this case, we can now add the position. Okay, so if you notice here, we add the position on the slab. So using the, what do you call that? The position on the Tekla tab, all right? So we can do the same here. This is the slab. And then this is the position, put it here, and then link that one to the position here. And then as you can see here, you can change the position now. All right? Controlling the position in Tekla structure. Okay. All right, so next step. Okay, so for the next step, we need to find the center point of the pad footing. Okay, so enable for us to find the center point of the pad footing, we need to add this axis or area. Sorry, we need to add this area. Okay, this is the area, and then get the area from the geometry, and then the centroid, we need to link that one to the linear array. Okay, so it's a bit plenty of command that we need to add here. So let's do that one by one. First is we need to add the area and then the linear array. Okay, area and linear array. So first, from here, okay, let's move it down a little bit. Okay, so here, double click, you type here area, and then double click, and then you type here linear array. So you can see here linear array. All right, so centroid, you just need to go to the geometry. All right, and then this geometry, I need to link that one here. All right. Okay, so next I have the area, I have the linear array. Okay, and then next is, so once you have the area and then the linear array, then we need to create the z direction for the direction of the points on the linear array. So meaning it will go up. So we need to put the z value or the z unit, okay, and then put the slider for the z unit, okay. So we put the z unit so that it will be automatically goes to the direction of the z direction, or going vertical. So this is the direction, and then here I can just simply add again the slider. Maybe again I'll just put here a minimum of 3 meters, and then let's say 10 meters. Okay, and then put it to this factor. As you can see here, I have now already the what do you call that, the points here. Okay, so that is the direction. And now we need to add the Tekla point. Just simply double click, you type here Tekla point here, and then I think geometry to this one, so that you can see that one in the Tekla structure. So you have now the Tekla point transferring to the Tekla structure software. Okay, again, from the polar array, you link that, you create an area, and then get the geometry, and then under the area, you can see the centroid, and then link that one to the linear array, and then control the direction, okay, control the direction. Okay, so this one is the direction. And I guess we need to also to add the count here. How many floors? So here I can just simply add another slider. Let's say minimum of 5 and then 15. But you can put more, of course. So here, just link that one to the count, and there you go. So I have 5, and then you can put more. So again, you can rename this one as you wish. So this one is floor height, and then the other one is number of floors. Okay, but again, you can always change the number of floors. I just limit that one here. As you can see, if you double click here, you can limit that one to 5 and to 15, but you can put more or you can put less as well. All right, so let's move on. So I have already this information from the Rhino to Tekla structure. Then let's move on here. Next page. As you can see here, we are now going to add the polyline, okay? Add the polyline, and then link all the points to the polyline, and then create and link that one to Tekla column. So meaning we're going to create the Tekla column. So at this point, we're going to connect the points and create the column. So for the column, it's either you use the concrete or steel column. At this point of time, I use the steel column, and then I use this profile. Okay, so again, let's move on. So from here, I'll just simply put this point aside here. Actually, we can delete that point later. It's not necessary. It's not necessary to be there. Okay. So again here, linear array. So we're going to if we go back to this one, as you can see here, we use the linear array to connect the points. So we need to add the polyline. So double click the canvas, then you type here polyline. This one. So look, if I click the polyline here, geometry to vertices, see, there will be a line here. Now, I need to use this polyline and add the column. So for the column, I can use now the steel column here. Let's put the column, and then before I link this polyline, I want to make it sure that I add the attributes here. So select these attributes, link here, and then for the profile, I'm going to select this profile, double click, and then you can now type the profile that you want to use. Let's say I will use the PD, which is pipe diameter, let's say 800 by 20. So then put that one on the profile. Okay. Okay, you may add also the class if you want to control the class. Let's say 115, and then here you control the class. So here you can control the class. Now, look, if I'm going to link the polyline to the curve here, so I can just simply put this one here, and then you have now this column. But if you notice here, the column is not on the center, so we can still add the position of the column here if you like. So just put the position here, and then click here at the middle, and then put the position, and that will be on the center. Okay, so that is the column. Now if I want to increase this one, maybe 5,000, there you go, a bit taller, or just double click if you want to put the exact value, then that's it. Okay, so all right, so now what we're going to do next is we are going to add another member here. So this time we created the column. Okay, so let's move back to the our PowerPoint. Then this time we are going to change the point order to create the beam. So earlier we saw that we showed that the linear the linear points is on the vertical side. Then we need to flip that one. Okay, we need to flip to make it horizontal and use that one to connect the points and make a polyline to create a beam. So this time I'm going to use the flip matrix. So here, if you notice here, add flip matrix and then add another polyline. Okay, so flip matrix. So here, so this is the polyline for the column. Okay, I'll leave that one aside. By the way, this is the Tekla point that I told you earlier. We can just simply delete that one. We don't need that one anymore. Okay, so here, just double click here, flip matrix. So if you notice here, it will swap the rows and column by simply flipping that one. Put this geometry here, and this data, you just simply add the polyline now. Vertices. Okay, and then we can now add the beam. So let's say the beam is something like this one. This is the beam. And again, I can just simply select these attributes. Okay, I will just simply copy that one by pressing, by selecting the part attribute, by selecting all, and then select one of the attributes and then press the Alt key. It will duplicate. Alternate key. Okay, it will duplicate. Now, before I move that one here. Before I link this one to this curve, so I'm going to change the profile catalog first. So let's say the profile catalog, I can just simply select any beam size here. Let's say the I section, or you can choose whatever section you like. Let's say I use the UB section. UB maybe 533 by 210. Okay, and let's say click here, and now select the polyline here. All right, okay, polyline. But if you notice here, the polyline is not closed, huh? So we're going to close that one later, but let's show first the attributes here. See, I have the attributes, I have the beam. Now to close this polyline, you just go to this close, right click, and then here under the set Boolean, you set this one as true, and there you go. So it become closed. And then here you can just simply change the position. Position here. There you go. Oops, behind. There you go. Okay, so we have now the beam. Okay, so the next step. Okay, the next step. Let's move on to the PowerPoint again, and this time, okay, we already added the beam and then change the point order, and next is we're going to add the slab. Okay, so for the slab, we're still going to use the polyline. Okay, at this time we're going to use the polyline of the beam. Okay, and then add the slab properties here. All right, the concrete slab. So here, this one, slab. So there you go. So just simply click his polyline and boundary, and there you go. You have now the slab there. But of course, we can always change the profile for the slab. So the profile is also the thickness, but again here I can just simply change all. I can also put the position here. Position. There you go. Yeah. And for the thickness, I can just simply type here 100, then 500. I think that one is under the profile. Let's see. Yeah, 500, it will be bigger. Yes. Okay. 100, and there you go. All right, so for the class number, you can always change also the attributes. Okay, so here you can always add the attributes here and then put it here and then change the class number. This one, the slider, put that one on the class number, change it to 6 maybe. Okay, there you go. So you have now the column, beam, and slab. Okay, with this simple um, what do you call that? Some simple equation here in our grasshopper canvas. Now, this time around, we're going to put some twisting on the column. All right. So enable for us to do that. Let's again look for the PowerPoint here, and let's see what we need to do next. Enable for us to have this twisted column. Okay. All right. So at this point of time, as you can see here, there are some previous link that we need to change. But here, first of all, is we need to create another polar array. Okay, we need to get another polar array, and then link the polar array to the area. Okay, so from the area, we're going to link the centroid to the polar array. Okay, so let's add that one, polar array, and also we need to add the degree, okay, the radian value for the rotation. Okay, so enable for us to do that one, we need to type 0 and then angle, then 2 times pi. Okay, so let's do that one first under the area here. So look for the area. Where's the area? So here, this is the area. So we need to do that one under this area. Okay, just move this one a little bit because we're going to use this one here. Okay, there you go. So just double click, enable for us to get the radian value. You just simply type 0 and then angle, then 2 times pi. Okay, enter. And then double click again. You type here again polar array. Yes. Okay. So now let's see. So this radian value of rotation, we need to link to the angle. Okay, and then the count. The count is need to be linked to the count. Okay, so centroid need to put that one on the geometry. Okay, so the centroid need to put it in the geometry, and then the number of okay, this angle, I need to put that one here, and then this one count to this count, and then transform. So let's see again here, as you can see here, transform need to put that one on the okay, so we need to add the transform command here, transform. All right, so again add here transform. Okay, so transform here, this one. All right, so transform, and then okay, so for this centroid we need to add that one to the geometry, I guess. So the centroid, we need to link that one to the the linear array need to go to the geometry, linear array. So for this two linear array, we need to link that one first to the transform. Okay, so where's the linear array here? So here, under this linear array, okay, this linear array, we need to go to this geometry here, and then these two, okay, this flip matrix and this polyline, I need to link this one here and then link this one here, and there you go. All right, Okay. So again, this is the angle. This is the polar array. So the centroid, you need to go to the linear array here. Okay, so as you can see here, the centroid needs to go to the linear array, and then the polar array. So there is again another the count, the number of floors. I need to put that one again in the polar array. So here the number of floors, I need to link this one to the it's there already here, polar array. Okay, so look, let's see if I put this one here. So if you notice here, it will twist. Okay, then if I change this one to a bigger one, point, select the point, and then make it bigger, and here number of footings, we can add the number of footings, and then change the height, change the quantity, and there you go. So here, as you can see here, you can change, you can rotate the building now using our Grasshopper script. Okay, so this is how you do that one. So this is a very simple example on how to use the uh, Tekla and Grasshopper live link. Okay, so thank you very much.